turn and pray. Heavenly Father, we just thank you again for the day. Thank you for the blessings you've given us. Thank you for the students here. Just pray you may help them in their classes, Lord. Help them to focus and be attentive, and help them to be diligent in their work. Just guide and lead in everything we do. In Jesus' name, amen. All right. Turn to page 282. I'll take that back. 290, I'm sorry, 290. Page 290. Let's look at number one. Suppose that f and g are continuous functions and that the integral from 1 to 2 f of x dx is negative 4. The integral from 1 to 5 f of x dx is 6. And the integral from 1 to 5 gx dx is 8. All right, we're going to use our integral rules. So letter A, account. The integral from 2 to 2 of g of x dx. What do our rules say? Page 290. Are the rules.
Since it's 2 to 2. I like it. Bottom 2. Because it's 5 to 1 g of x. dx equals 8.
All right, but we had a rule that when the upper limit and the lower limits were the same. What was the rule?
It will be plus and minus.
No. Look where it's there. Look where the upper limit and the lower limit are the same. What's my rule?
Oh, it equals 0.
Equals 0 when the upper limit and lower limit are the same, it's equal to 0. Letter B, 5 to 1, g of x dx. Allie,
Would it be -8?
-8. When we switch the limits, upper limit and lower limit, we're going to do what? Is equal to the opposite, correct? Switch the signs. Letter C, the integral from 1 to 2 of 3 f of x dx. Caleb? -12. When we have a constant, we're just going to take our limit, our integral, and multiply it by my constant to -12. Letter D, Connor. Limit as f of x dx of 2 to 5.
Two. No.
remember we don't have one like that, so we need to set up our equation here. So the integral from 1 to 5 equals the integral from 1 to 2 plus the integral from 2 to 5. Is that correct?
Yeah.
Which one are we looking for?
2 to 5.
2 to 5, so we need to get rid of this one. So the integral from 1 to 5 minus the integral of 1 to 2 equals the integral from 2 to 5. What is the integral from 1 to 5?
6.
Minus what is the integral from 1 to 2?
-4.
So therefore that equals the integral from 2 to 5, which is going to be
10.
10. Letter E, the integral from 1 to 5 of f of x minus g of x dx. Grace? -2. Letter F, the integral from 1 to 5 of 4f of x minus gx. Noah, give it a try.
Maybe 24 minus 8.
Which is?
16.
16, that's correct. Look at number 3. Suppose that the integral of 1 to 2 f of x dx equals 5. Find each integral. Letter A.
We were at number 5, you said?
What's that? Number 3.
Oh, number 3, sorry.
The integral from 1 to 2 fu du.
It's 5.
5. The integral of 1 to 2 of square root of 3 fz dz. Anyone?
5 square root of 3.
5 square root of 3. The integral from 2 to 1 ft dt.
-5.
-5. And the integral from 1 to 2 of negative fx dx.
-5.
-5. Alright, let's look at number 4. Suppose that the integral from -3 to 0 gt dt equals square root of 2. Find each integral. The integral from 0 to -3 gt dt. Connor.
Negative square root of 2.
Letter B, integral from -3 to 0 gu du. Grace.
E square root of 2?
Correct. Letter C, the integral from -3 to 0 of negative g of x dx. Kim.
Negative square root 2.
Alright. And letter D, the integral from -3 to 0 gr dr over square root of 2. Caleb. 1. Let's look at number 5. Suppose that f is continuous and that the integral from 0 to 3 fz dz equals 3 and the integral from 0 to 4 fz dz equals 7. Find each integral. The integral from 3 to 4 fz dz.
1.
Again, we're looking at this. Set this up.
Sorry, 4.
Does everybody agree? 4? Everybody see how we did that? Again, they gave me 0 to 3, and they gave me 0 to 4. Alright? What does the integral from 0 to 4 equal? That equals integral from 0 to 3 plus the integral from 3 to 4. Would everybody agree? Yes? Alright, how do I find the integral from 4 to 3? That's the integral from 0 to 4 minus the integral from 0 to 3. That's how we get 7 minus 4, or 7 minus 3 rather. Alright, letter B. Integral from 4 to 3. Connor.
-4.
Okay, we switch the limits, so we switch the sign. Number 6, suppose that h is continuous in that -1 to 1, hr dr equals 0, and from -1 to 3, hr dr equals 6. What is the integral from 1 to 3, hr dr? Noah, what do you think?
For, that is just 6.
Alright, how do you get 6?
Good. Oh, wait, no, never mind. So you do 3 to -1 is equals the interval of 3 to 1 plus the interval of 1 to -1. Alright, so it would be 6.
Correct. So -1 to 3 equals -1 to 1 and plus 1 to 3, and we're looking for 1 to 3. That's integral from -1 to 3 minus the integral of -1 to 1. Okay? So it'll be 6, and then the negative integral of 1 to 3 hu du would be what?
6.
Everybody agree? 6, correct. Let's see. So number 15. Number 15 says that f of x equals x plus 4, and when between -4 and -1, and negative x plus 2 between -1 and 2. Find the average value of the function on the interval without integrating by appealing to the geometry of the region between the graph and the x-axis. Okay, how do we find average value?
No, that's the actual area. Average was 1 over b minus a times the integral.
And again, when I'm taking the integral, I'm finding what? Area underneath the curve. So here we have a curve that forms a triangle. How do I find the area of the triangle? 1/2 base times height. What is my base?
6.
Everybody agree?
Yes.
What is my height?
30.
Everybody agree? So 6 times 3 times 1/2 is 9. And I multiply that by 1 over my b is 2. My a is -4. So 1 over 6 times 9, which is
3 over 2.
3 over 2. Look at number 16. I have this diagram, which is f of x equals 1 minus square root of 1 minus t squared. And we're looking for the integral from -1 to 1. Alright, but we don't want to use we don't want to integrate, we want to use area between the curve and the x-axis. Alright, so what do we have here?
Could say a rectangle and a semicircle.
Alright, a semicircle. And what do I know about the semicircle?
It's inscribed in
In a
the
rectangle.
Alright, inscribed inside a rectangle. What else do I know about the semicircle?
Vertex is 0, 0.
Correct? What else do I know about the semicircle?
Radius of 1.
It's,
Alright, the radius is 1. Okay? So how can I find the area of the shaded region?
Area of the rectangle minus the area of the semicircle.
Right? That's length times width minus
R squared half.
pi r squared over 2. What's my length?
2.
What's my width? What's my radius? So I get 2 minus pi over 2, which is 4 minus pi over 2. I'm looking for the average area. My average area is going to be 1 over b minus a. So that's going to be 1 over my b is
1.
minus my a, which is
Negative 1.
-1, which gives me
2.
1 over 2 times 4 minus pi over 2, which gives me
4 over pi. 4 minus pi over 4.
okay? Look at the next one. F of t equals sine t. Going from 0 to 2 pi. What is my area? Or what would be my integral using the areas between the curve and the x-axis?
Well, we're not, they wouldn't cancel each other out because we're not doing the negative area, right?
Yes, we are.
So
So
it
it's
would
0.
be 0.
It would be 0. So this is the same as this. This is positive, this is negative. So we have 0, and it would be 1 over 2 pi minus 0 times 0, which equals 0. Well, look at the next one, tangent. And we're looking between negative pi over 4 and pi over 4. Again, this would be 0 because we have the same positives as we have negative. That make sense?
How do you get the, B and A?
Those are your limits.
Oh, okay.
Okay. Okay. Any questions there?
So we're gonna stick with negative area unless, yes, unless it tells us to not do it?
Yes and no.
If it asks for the total area, then we would not take into consideration negative area.
Correct.
But if they ask for the integral, then it's negative area. Or
Correct. All right. Look at theorem 4. Fundamental theorem of calculus, part 1.
Wait, which one?
On page 294. Sorry, 294. Says f is continuous on the integral from a to b, then the function f of x equals the integral of a to x of f of t dt. has a derivative at every point x and the interval a to b, and then df over dx will equal the derivative of the integral. Because what is the integral? The integral is just the opposite of the derivative, or vice versa. What is the derivative? That is the opposite of the integral. The integral, when we have the integral, the function here, as you see, is a derivative. And when we take the integral, we are taking the anti-derivative. We're taking the antiderivative here, correct? The antiderivative of the derivative would be the function. If I take the derivative of the function, then I get the derivative. Okay? So that's why they say that the derivative of the function is going to be the derivative of the integral. Because what's the integral?
It's the antiderivative.
The function. Correct? So when I take the derivative of the function, that's the same thing as I'm taking the derivative of the integral. So that's what that theorem is stating. It's kind of a going around in a circle type thing. But what I need to understand is that this here, when I take the integral of the derivative, I am actually finding the function, the antiderivative, which we have done. All right? So we get to the next box, we say d over dx of the integral from a to x of f of t dt is going to equal f of x. So let's look at some of the examples. It says find the derivative of the integral from negative pi to x cosine t dt. The lower limit is always my constant. My upper limit is my x. So basically, the function is, because of this here, all right, the derivative of from a to x, f of t dt equals f of x. If we notice, all we're doing is substituting in my x. We're on page 295. Look at the next one. Derivative of the integral from 0 to x of 1 over 1 plus t squared dt. What are we doing? We're putting the x in for the t. So my derivative of that integral would be 1 over 1 plus x squared. Okay? Because when we take the derivative of the integral, we're just basically canceling it out, and we're getting this. If I take the derivative of this integral, which the integral is the function, I'm just getting this function, this derivative here. Because again, remember, this is the derivative. Here. That is a derivative. All right? So it would look something like this.
But then when we graph it.
If I have the integral of, let's say x. To take the integral, I'm going to take the antiderivative, which is x squared over 2. Correct? So if I take the derivative of that, well, what does this equal? X squared over 2. We could really say plus c. So now when I take the derivative of that, what do I get?
Okay,
Get x. So that's basically what we're doing. We're just canceling it out. It's sort of like it's sort of like squaring the square root. What happens when you square a square root?
it just
Just cancels out and gets the number inside. So what happens when we take the derivative of a integral? It cancels each other out, and we're just left with the number that we have. That's basically what it's talking about.
So when we would graph, in the previous section, when we graphed the function and find the integral with the area and the curve, is that the graph of the slope of the graph?
That was the graph of the derivative.
Oh, so it wasn't the graph of
No.
okay.
Flip the page to the next one. This is now where it gets a little tricky. All right, because my number up top is not an x, it's an x squared. All right, so what I'm going to use my u substitution. Okay, so I'm going to take d over dx, integral from 1 to u, okay, cosine u du, and then du equals x squared. I'm sorry, u equals x squared, not du, sorry. I substitute with a u, not du. U equals x squared. So remember my chain rule. D over dx at times, and you get dx, I did that wrong. D over du times du over dx. Well, what happens when I multiply those? They cancel each other out. So I get d over dx. Which I'm going to do the same thing here. What is d over dx of 1 to u of cosine u du? I'm sorry, this should stay t, cosine t dt.
It would be cosine u d.
It would be cosine u du. And then what is du? 2x dx. Correct? But then I just take this and substitute back in here. So I get cosine u times 2x dx, which is 2x cosine u dx. And I substitute the,
Wouldn't it be like,
then I substitute the u back in. So I get 2x cosine x squared.
And you don't multiply by dx.
No, because basically what we're substituting in is du over dx equals 2x. We're substituting it back in for du over dx.
Why the cosine u,
so there is no d?
There is no dx, correct. Because again, remember, we're not finding the derivative, we're taking the derivative and finding the function. So let's look at another example. So it's sort of u substitution. So we got y equals the integral from x to 5 of 3t sine t dt. All right, again, normally the x is on the top. I have my lower limit, the number on the bottom. So I flip those. When I flip my limits, what's the rule? Change to negative. So So now what is my function? Three x. A negative 3x sine x. All right, so listen to the next one. This one's interesting. Two plus t. Well, here you notice we don't have a constant at all. So we go back to our rule that we used before, and we set up, all right, this is the integral from 0 to x squared, which equals the integral from 0 to 2x, plus the integral from 2x to x squared. So we're looking for this. Well, this is going to equal the integral from 0 to x squared minus the integral from 0 to 2x. Okay? Does that make sense to everyone? So now we're just going to do, now we just have to evaluate the integral from 0 to x squared of 1 over 2 plus e to the t dt minus the integral from 0 to 2x of 1 over 2 plus e to the t dt. Well, again, remember our chain rule is the derivative of the function times the derivative of the composite, right? So what was my composite? The x squared. So I'm going to have 1 over 2 plus e to the x squared times 2x minus 1 over 2 plus e to the 2x times 2.
Is that first E supposed to be 2, or?
Oh yeah, I'm sorry, it should be a 2. Yes. So therefore, when I simplify this, I get 2x over 2 plus e to the x squared minus 2 over 2 plus e to the 2x. Because again, this is a composite, so if I substitute that with u, I'll be substituting u in and then putting the 2x squared back in. And multiplied by the composite, or the derivative of the composite. So let's look at some examples. Turn to page 302. Again, how do I know when I have a composite? Anytime that the upper limit is not an x, I would have a composite. So take for instance number 1 on page 302. Y equals the integral from 0 to x of sine squared t dt. Find the dy dx. That would equal what? Sine squared x. Number 2. From 2 to x, 3t plus cosine squared t squared dt would be? What would it be? 3x plus cosine x squared.
Oh, sorry, I was in number 3.
All right, number 3 would be?
X squared plus q
Minus x.
Oh,
To the 5th. Number 4 would be?
Square root of 1 plus e to the negative 10.
e to the 5.
E to the 5x.
E to the 5x. And again, when that upper limit is just an x, all you're going to do is substitute the variable in with the x. That's all you're going to do. Number 5. tangent cubed x, everybody agree? Number 6,
EX.
Secant.
okay? Alright, so let's skip down to number 9 now. Alright, number 9, now we have the number up top, not an x. So it's a composite. So we're gonna take the derivative times the derivative of the composite. So e to the x squared, or t squared, would just be,
1 over x squared. Oh,
Mm.
no, it would be e to the x squared. Oh, no, no,
X
2.
squared.
alright, so we got integral from 0
Wait, what?
2x.
x squared of e to the t squared, right? So we're gonna take the x squared, put it for the t, so e to the x to the 4th times the derivative of x squared, which is 2x. So number 10 would be
2x cotangent 3 to the x squared.
okay, 2x cotangent 3x squared, correct? So number 11, Grace, what would you get?
Would you get, the square root of 1 plus 5x squared over 5x? Is that right?
When you say 5x squared, is it 5x squared or is it 5x squared?
5x squared,
Okay. Over,
5x.
alright? Now remember, if with an x up there, so it's a composite, so what else do you have to do? Or the chain rule, what else did you have to do? Take the derivative, which you just did, you just took the derivative. Now you have to multiply it by the,
By 5x or by 2?
the derivative of the composite, and what's your composite? Alright, so remember what we did here, the x squared? So we took the x squared in for my t, but then I also then multiplied by the derivative of my composite.
So you would multiply by 5.
Then you would multiply by 5, and then you would simplify. Which, how would we simplify that?
Would you cancel out the 5?
Okay? So my final answer would be simplified,
Square root of 1 plus 5x squared.
simplify it,
25x squared
okay,
over x.
over x. Alright, Connor, next one.
So if the x is in the bottom, do we still do the same thing by putting the x in?
You're in 12.
No, oh, whoops. So 1 plus sine squared pi minus x over 1 plus cosine squared pi minus x. And then, times it, you take the derivative, so it'd be -1.
That would be negative 1 plus sine squared of pi minus x over 1 plus cosine squared pi minus x, correct? Alright, the next one, Noah.
Negative ln of 1 plus t squared.
Well, remember, we're taking out the t, putting in negative ln times 1 plus x squared. Number 14, Caleb.
Negative square root of 2x to the fourth plus x plus 1.
Okay, number 15, Akem.
Negative x, negative 3x squared times cosine x cubed all over x to the 6 plus 2.
Very good, excellent. And number 16, Ally.
So negative, and then negative 10x times, it would be 25x to the fourth minus 10x cubed plus 9 all over, like cubed, 125x to the sixth plus 6.
Okay, very good. 17. Grace, give that one a shot. First thing you do what?
First thing you have to do is plug 0 into R.
Nope. Oh, what did we say? We said that,
The lower limit is an X, so we use it.
okay, so what are we gonna do? Someone help us out, what are we gonna do, Connor?
We would, it'd be negative, right?
But we're, to do that, what are we doing?
We're putting square root of x into, for R.
Correct, we're putting the square root of x on top and putting the number on the bottom. And when I flip the limits, it does what?
Makes it negative.
Makes it negative. So now we got sine r squared dr. Alright, now what are you gonna do? You're gonna do what with this?
Plug the square root of X into R.
Okay, so that makes sine of
Sine of X.
x. And then, what are we gonna do?
And then you take the derivative square root of X.
Which is?
So that's X to the 1/2. And then you multiply that by sine X.
Well, the square root of x is x to the 1/2. What's the derivative?
Oh, 1/2 X to the negative 1/2.
There you go.
And then you multiply that by sine X.
And then we have the minus sign, correct?
Yeah.
So there we go. So we have negative sine x over 2 square root of x. Okay?
Okay.
Alright, so we're looking at some more of these tomorrow? Have a good night.